Hello everybody and welcome to the first video on exam questions for binomial distribution. So in the first question we're told that the probability of a day having severe fog is 0.06. And first we're going to work out the probability that in a given week there is no day with severe fog. So we can put x equal to 0 because we want no days with severe fog, and because it's exactly 0 we can use the binomial formula to work this problem out, where x is 0, n is 7 because there's 7 days in a week, and p is 0.06. So if we put all the numbers into the formula correctly and use the combinations formula to work out the first bracket, 7 choose 0, then we get the answer 0.6485. For 3 or more days with severe fog, x is greater than or equal to 3. And as we've mentioned in previous videos, that's the same as saying 1 minus the probability that x is less than or equal to 2. And if it's less than or equal to 2, it could be 0, 1 or 2. So we can use the binomial formula to work out the probability when x is 1 and x is 2. And we already know the probability when x is 0 because we've just worked it out. So if we add those three numbers together and subtract them from 1, we get our final answer, which is 0.0063. Now the second part of the question asks us if we already know that on a given week there are 3 or more days with severe fog, what's the probability that there were exactly 3 days with severe fog in that week? Now this is conditional probability, so we have to divide the probability that there are exactly 3 days of severe fog in that week by the probability that there are 3 or more days of severe fog in that week. So first we work out the probability that there were exactly 3 days of fog in that week using the binomial formula, and that comes out at 0.0059. And then we divide that by the probability that there were 3 or more days of fog in that week, which we worked out in the previous section, and the final answer is 0.9365. In the next question, we're told that the probability that Anna will have to rescan an item is 0.15. This means if the barcode is read successfully, a first-time item, the probability is 0.85. We want to find the probability that after scanning 40 items, she has more than 31, but at most 37 first-time items. This means we need to find the probability that x is greater than 31, but less than or equal to 37. And this is equal to the probability of x being less than or equal to 37 minus the probability of x being less than or equal to 31. Now we know n is 40 and p is 0.85. And in this example, we're going to use a calculator to work out the probability that x is less than or equal to 37 and the probability that x is less than or equal to 31. So we can calculate the answer as 0.816. We're then told the probability of Bertie scanning an item correctly is 0.7. He scans 50 items and we want the probability that he has at least 35 first-time items. So we want the probability of x being greater or equal to 35. And as we've spoken about previously, that is equal to 1 minus the probability of x being less than or equal to 34. Now n is 50 and p is 0.7, so if we get the tables up for n equal to 50 and read down the 0.7 column, we can get the value for x is less than or equal to 34 and work out the answer to be 0.569. And in the last question, we have binomial distribution of 13 0.16, and we want to determine x is less than 2. Now, the probability of x being less than 2 is equal to the probability of x being less than or equal to 1. And we can work out the probability of x is less than or equal to 1 by adding the probability of x is equal to 0 plus the probability of x is equal to 1. We know that n is 13 and p is 0.16, so we can use the binomial formula to work both of these calculations out. And remembering to use the combinations formula to work out the first bracket, 13 choose 0 and 13 choose 1, we can calculate our answer, which is 0.36036. And finally, if 2 independent observations of x are made, find the probability that exactly one of these observations is equal to 2. So we could have the probability of x equal to 2 for the first observation, and then have to times it by the probability of x not equaling 2, or vice versa. We can find out the probability of x is equal to 2 using the binomial formula, using the combinations formula to work out 13 choose 2, and then we can put the number back into the equation in red and get our final answer of 0.4146. That's it for this video. As always, thanks very much for watching, and if you could please hit like and subscribe, I'd really appreciate it. See you soon.